Number 5. Convert the parametric equation to its implicit rectangular form. Graph it. Find the equations of any vertical or horizontal tangent lines. Okie dokie. So, how are we going to do this? Let's go ahead and write our equation. Alrighty, well, from my x parametric right here, I am going to get x minus 2 from that, x minus 2 squared over 4 squared, plus, from my y equation, y plus 1 squared over 3 squared. And it's an equation, so it has to equal, and it is equal to 1. So there's that equation, which is nice. What do I want to do? There is the rectangular form, and then we want to find some tangent lines. So let's go ahead and sketch this real quick. I'm going to move this over here to make my life easier, and I'm going to erase that little awkward bit right there. And let's plot this, which will help me find those tangent lines. I'm going to find these tangent lines without even taking a derivative, which is nice. So I am going to plot this right there. Let's draw a horizontal axis as well. And let's plot our center, which has an x value of positive 2 and a y value of negative 1. So it is right there. And now I'm going to plot the rest of it. Notice that 3 squared underneath the y. That is telling me that I should go up 3. So 1, 2, 3 right there, and down 3. 1, 2, 3 right there. So let's note these y values. That y value is y equals positive 2. Let's note this y value down here. That is y equals, what is that, 1, 2, 3, 4, it looks like. So y equals negative 4. Now let's look at that 4 underneath the x. That is telling me from that center, go 4 to the right. So 1, 2, 3, 4. And again, let's just go ahead and note the x value here real quick, just for fun. What is that x value? That x value is x equals 1, 2, 3, 4, 5, 6. So let's say x equals 6 right there. And then again, that 4 from the center is saying go 4 to the left as well. So I'm going to go 1, 2, 3, 4 right there, which is taking me to the x value of negative 2 right there. Okay, so let's now draw in this ellipse. It's going to go whoopie whoopie doopie day, curve around like that. And now let's think about these tangent lines. Tangent line on the right and left on the sides of this ellipse have to be vertical. Boom, right there. The tangent lines on the side of an ellipse will always be vertical, so I get 2 right there, nice and easy. And now let's look at those other special points on here. How about those up and down pieces right there? Because if you are at the top and bottom of your ellipse right there, you will have horizontal tangent lines. Always, always, always. So now the last thing we want to do is just write the equation of these lines. Oh wait, we've already done that, because if you're writing the equation of a vertical line, it is just x equals whatever x value the line is lying on, and that x value is negative 2, and the other x value is positive 6. And to write the equation of a horizontal line, it's just y equals whatever y value it's going through. So y equals positive 2 and y equals negative 4. And just like that, we are done.